This PetroSkills PetroAcademy skill module covers the introduction to perforating at the core knowledge level. Oilfield perforating operations are often simply defined as the act of establishing communication between a wellbore and the intended producing reservoir. Several different perforating tools and methods are introduced in the module. The term perforating gun is used to identify the mechanical systems that actually fire the perf charge explosives. For a completions engineer, assembling a completion program to incorporate choices of the available perforating tools and methods will provide the best opportunity to maximize well flow rate. Since perforating incorporates the detonation of perforating explosive charges, it is imperative that safety always be at the top of the list of controllable variables in planning and executing a perforating job. A properly designed perf job requires that an engineer make critical initial perf job design decisions regarding depth of perf penetration, perf hole size, shot density, shot phasing, and others. The act of detonating a perf charge in a well to achieve communication between the wellbore and the reservoir involves the charge penetrating the well casing and cement sheath around the casing, as well as the hole created into the depth into the formation. This activity often leads to perforating debris of steel, cement, rock, etc., entering a perforating tunnel and resultant damage. Be aware of the important variables in developing a perforating program to make informed decisions about the variables that will result in establishing the proper downhole configuration of perf hole diameter, depth of penetration, and perf hole numbers, all necessary to maximize fluid flow rate from the reservoir into the well. Perforating is an important step in completing a well. It addresses establishing communication between the well and the producing formation. The process of perforating will be reviewed along with some shaped charge history and safety issues. The concept of the shape of a charge and results due to the shape of the explosive will be discussed, as the shape of a charge makes a significant difference in charge performance. A look at the three primary perforating techniques: performance of perforating guns, the charge carriers that bring the charges into the well, some operating procedures, and the selection of systems will be addressed. The concept of extreme overbalance perforating and operational issues no longer practiced in the industry will be examined. A well that successfully had its production casing cemented next requires establishing communication with the producing formation. This is achieved with perforating technology. Perforating design leads to establishing a desired perforation tunnel depth of penetration and entrance hole size. The top part of the illustration shows what the engineer intends. What actually occurs is demonstrated in the bottom regarding perforation tunnel damage due to the detonation of the charge, the crushing of the rock, and all the debris that is carried into the tunnel. Perforation tunnel damage in the lining of the perforation tunnel reflects possible significant damage. The damage will have a certain thickness, often around a ½ inch, and a loss of permeability, roughly 50 to 75% loss compared to the original permeability of the formation. Historically, oilfield perforating charge explosives have been shaped differently and with different construction designs. Over time, perforation charge designs have evolved. World War II led to a lot of research and development regarding the shape of charges and their performance. In 1962, the American Petroleum Institute developed the original API 43 standard for testing charges. That original standard evolved such that in 1991, the 5th edition was published. Before the 1950s, plugging of perforations was common. Perforating practices and operations were carried out without a concern for wellbore fluid environments, often with differential pressure into the well and with mud in the hole, all of which led to creating perforation damage. The ability and the necessity of maintaining clean perforations was not understood or appreciated. The facts of formation compressive stress and how this stress affects overall perforation performance was not really known or was ignored. In addition, there was a lack of understanding of the overall perforating process. Little was known about the positioning of the gun in the well, gun clearance, and related decisions regarding other perforating engineering factors. Historically, bullet-shaped perforating charges were once used. They preceded the concept of the shaped charge. The bullet did perform significantly well. They would create a deep penetration if the formation was soft, and the hole essentially reflected what appeared to be caused by a bullet. The steel through which the bullet perforator penetrated was burr-free, and typically the choice of the gun type was limited.